Okay, so our topic today is arc lengths and area of sectors. And your objective or the essential question, and I guess this isn't really a question as much as it is a task. If you can compare arc length to circumference, formulas you don't have to rely on formulas to find answers. You can rely on your brain because you understand it deeply. Same thing with the area of a sector in comparison to the area of a circle. Okay, and you did some intuitive work for warm-up, so I think that hopefully this lesson will make a lot of sense. So here we go. Let's start with arc length. Okay, arc length. So let's draw an arc. I did not mean to do that, so let's try going back. There we go. Let's draw an arc length. So I'm going to grab a colored pen here, and I'm just going to go around just a little section of my circumference here. And I'm going to draw a centralized angle, theta. Theta encompasses or is subtended from the arc. Arc lengths are typically denoted by a lowercase s. And the other thing that's really important when we're talking about arc length is we either need the diameter or we need the radius. And of course, if you're given diameter, you just cut it in half to find the radius. So this is the data you need. In order to find an arc length, you need an angle measure and the radius or the diameter. Okay, so arc length, or S, intuitively, if you think about it, an arc length is just a fraction or a portion, if you'd rather, of the circumference of a circle. I'm not going to finish the word circumference because I'm out of room. I think I'm not going to. And so if you can access the formula for the circumference of a circle quickly, and you should be able to, circumference is 2 pi radius, because if I'm going to go around the circle in radians, I'm going to go 2 pi radians. And a radius is the same measure as a radian. Okay, but if I want a fraction of the circumference of a circle, I just want a percentage of the perimeter or the circumference. So if theta is given to me in degrees, I do have to pay attention to that and have a little bit of base knowledge here. If theta is given to me in degrees, then I can say that the arc length is equal to theta divided by 360. That's our fraction of the whole circumference times the circumference, or a percentage of the circumference. So if theta is given to us in degrees, this is the formula that we could use. And I think it's pretty intuitive if you think of it as just a fraction of the full circumference. If theta is given to you in radians, however, we can start off with the same idea, that the arc length is equal to theta over 2 pi radians of the full circumference. So it's a percentage of 2 pi times 2 pi radians. However, I think that if I wanted to derive a simpler formula, I could do a quick cross simplification. I'm going to grab up my pencil so that I can show you a quick simplification. This formula tends to be a little simpler. Doesn't tend to be, it is a little simpler, because I can cross simplify the 2 pi with the 2 pi. So most textbooks will say that this is S equals RO. And there's a little mnemonic that'll help you to remember it. And it goes like this: standing room only. Or you could come up with your own mnemonic, of course. All right? Now, let's go and do two problems. Let's do example 1. Ready? All right. So it says, if a circular arc of the given length S subtends the central angle theta on a circle, find the radius. So we're talking about arc length. We're talking about theta. A central angle, we're talking about radius. So I think circumference would be the place that we would go. So let's draw a picture first. So we have a central angle of 5 radians. I want you to think about how many radians are in a full circle. How many radians are in a full circle? 2 pi. What's 2 times pi? 6.28? So 6.28 radians. So if I'm starting here at 0 and I want to do 5 radians, well, let's say here's my radius. That's my measure for my radius, which I am looking for. So what I want to do is I want to do 5 lengths that are about the same length. So there's 1 radius, 2 radius, 3 radius, 4 radius, 5 radius. I'm a little bit off, but that's okay. This is 5 radians. That's a huge angle. Okay, and our S is 9 feet. The whole thing. So what is our radius? How would we determine that? This is 1 radius, 2 radiuses, 3 radiuses, 4 radiuses, 5 radiuses. 9 feet equals 5 radiuses. Interesting. So let's plug it into our formula. SRO. 9 feet equals 5 radians. And it's in radians, so I can use SRO times radius. We divide both sides times 5. We get the radius is equal to 9/5 feet, or 1.8 feet. What? I wrote 1.8. That's a slash. So if you think about it, 1.8 times 5, right? 1.8, that's another radius. There's another one. If you're just thinking through it, I always like to make my answers make really good sense to me. Yeah, that's 9, right? It's definitely 9. Okay, so there you go. Let's go to B. So B, you have an arc length of 3.5 inches, and your theta is in degrees. So you have a choice to make here. You can either use our formula, theta over 360 times 2 pi r, and plug that into your calculator, or you could convert 40 degrees into radians and use SRO. I don't care which one you do. So you tell me, what do you want to do? Use the formula for arc length in degrees, or convert our degrees to radians and use SRO? SRO? Somebody spoke up, so that's what we're going to do. We're going to convert our theta from degrees to radians. Do a quick little cross simplification. 20 goes into both of those 2 times, so that would be 2 pi over 9. So that's what theta equals in radians. So that's a quick conversion. It's not difficult to use, and then I could go back and I could do SRO, because now I have my theta in radians. So 3.5 is equal to 2 pi over 9 times radians. I think that would be a great way to go about this problem if it's what you'd rather do. Okay, so how could I quickly, in one step, isolate R? That would be but then I'd still have to divide by 2 pi to isolate R. I want to do it in one step. divide by 2 pi over 9. How about if I multiply times its reciprocal? That's the same as dividing by a fraction, multiplying by its reciprocal, right? But that would allow me to cross simplify. But of course I have to do that on the left and the right. So we get r is equal to 9 times 3 times 3.5 over 2 pi. What's that? 28 and a half over 2 pi. We'd plug that into your calculator. So please do that. I'm getting 5.013 inches. Okay? It's not. It's 5.013 inches. No, it can't be. Can it? Oh, it's 9 times 3.5. Yes. 9 times 3.5. Here, I'll put parentheses. There we go. All right. There we go. So that's using SRO. Even though we weren't finding arc length, we used SRO to help us find radius because we had arc length and theta. Let's go back now to talk about the area of a sector. Right? So area of a sector, let's draw a sector. So a sector is just a central angle so it's basically all that space. It's just a portion or a section of the circle. And what we need here is theta, whether it's in pi or degrees or radians, and the radius. Okay, so an area of a sector, which usually is just A, but I'll draw a little version of a sector, just a little visual. Area of a sector is a fraction of the area of the whole circle. Or a percentage, or a portion. So what formula is important for you to access is the formula area of a circle is pi radius squared. That's the important one to know. Okay, so if theta is given to you in degrees, we're just going to take a fraction of the area of the full circle by saying the area of a sector is equal to theta divided by 360 degrees times pi radius squared. And if theta is given to you in radians, it is important to distinguish area of a sector is equal to, instead of theta over 360, we'd have to do theta over 2 pi radians. So a portion or a fraction of the area of the full circle. However, this equation, like I mentioned to you in warm-ups, can be simplified. Yes, I can cross simplify pi, and I get a more simplified version of the area of a sector, as long as it's in radians. Radius squared theta over 2. Okay, and you just have to decide what you want to do with that. But there are your formulas that will help you to find what you need. So let's take a look at number 2. Find the length of the arc of the colored sector in the figure. Now, I don't think yours is colored very well. You probably can barely tell that it's shaded. Copy machines don't copy in color. All right, so we are looking for the arc length. And so that's the first instruction. Find the length of the arc. And then the second instruction is find the area of the sector. So here's what I want to know from you. We have theta in degrees. Do we want to work in degrees, or do we want to convert to radians and work in radians? Degrees? Okay. So if we want to work in degrees, okay, I'm just going to go back and show you the formula for degrees. That's this one and this one. Or we can work in radians, which is the blue formulas. Are you sure you want to work in degrees? Do you want to amend your suggestion? No. Radians. Okay, the vote is radians. If you want to do it in degrees, you can. You'll get the same answer that I do. All right, so let's convert 85 degrees to radians. So theta, 85 degrees. So we'll cross simplify that. 5 goes into 85 17 times. 5 goes into 180 36 times. And so in theta, and maybe I'll just come over here and mark it, 17 pi over 36, so that I have it in both measures. Okay, so we've converted. It's not difficult to do those conversions. Now we need to find the arc length. So we need S. So we want S equals radius times theta. Here we go. S is equal to radius 4 times 17 pi over 36. Quick cross simplification. 4 goes into 36 9 times. So we get the arc length is exactly 17 pi over 9 centimeters. However, that's not a very friendly answer. So let's convert that in your calculators. And by the way, do you know the conversion button on those little scientific calculators? Do you know where it is? Because if you plug into that little calculator 17 pi over 9 and hit enter, it's going to tell you 17 pi over 9. But the little arrow button, the double arrow above the enter button, see it? If you push that button, it'll convert the answer to decimal form for you. And if you push it again, it will put it back in fraction form. What you got? 5.934 centimeters. It's a really nice little tip. It's just the little button that looks like this. It's the conversion back and forth between fraction and decimal. That's what that button does. Okay. All right. Now we have to find the area. Ready? So we're going to use the formula area of the sector is equal to radius squared theta over 2, because we have the radius and we have theta in radians. So area of the sector is equal to radius squared, so 4 squared, times theta, 17 pi over 36, all over 2. And of course, you could sit here and simplify that or just plug it straight into your calculator. That is a terrible sector. You guys go ahead and keep working. I'm going to redraw that. So I plug that in my calculator and I get 34 pi over 9 centimeters squared. And if I convert it with my conversion button, 11.868 centimeters squared. And there you have it. Do you have any questions? All right. So we just have one more problem set to do. Okay. Here we go. We have, and the reason that I put this problem in here is more because the wording of the question is kind of strange, but it's the same wording as the wording on the assignment that I have given you, so I want you to be able to interpret what you're being asked. So here's what it says. A central angle theta is subtended by an arc 10 centimeters long. So that represents my S. It's my arc length. Right? Long is just a version of length. So arc length, S, on a circle of radius 4 centimeters. Such a strange way to talk about it. So we've got theta. We've got arc length. We've got radius. Yeah, we have all of that. So I'm going to come over here and draw a picture real quick of what that looks like. So it has an arc length of 10 centimeters and a radius of 4 centimeters. So here's what I'm thinking. If this is 4 centimeters and I'm going around this 10 centimeters, I can kind of eyeball that that's about 4 centimeters there. And that's about 4 centimeters there. And then that would be 4 more centimeters. So maybe 2 more centimeters. So I'm thinking I'm looking at this measure of 10 centimeters. Now, how many radians is that? Think about it. There's 1 radian, 4. Here's 2 radians, 8, and 2 more centimeters. 2.5 radians? Do you guys see it? I see it. Okay, so here's what you have to do. Find theta in degrees. You have to find theta in radians. And you have to find the area of the circular sector determined by theta. So what do you want to do? Find radians or degrees first?
Degrees.
You want to find degrees first? You found degrees. You didn't find radians first? I thought we just found radians in our head. 2.5, right? We did. So if I say this, SRO, 10 centimeters is equal to radius times theta, which is, oh, my radius is 4. Radius times theta, divide by 4, because it's in that's radians. I get theta equals 5/2 radians, or 2.5 radians, which is what we determined when we drew the picture. And hopefully that's helping you to understand radians better. I'm hoping. Okay, now I want to find theta in degrees. So here's my question to you. Do you want to just convert these radians to degrees, or do you want to go back and go through the formula for arc length to solve for theta? What do you want to do? Convert from radians to degrees. So we would just do 2.5 times 180 degrees over pi to find my degrees. There's alternate ways to go about that, just like there is in everything we do in math. But I believe that would be a pretty quick way to do that. So here's what I'm getting. Theta is equal to approximately 143.239 degrees. And if you look at the angle that I sketched over here, I did a pretty good job. Questions? Okay, last one. Find the area of the circular sector determined by theta. So we want to use radians or degrees. Do you want to use 2.5 or 143.239? Radians. So we would go, area of a sector is radius squared, so that would be 4 squared, times theta, 2.5, all over 2. So 16 times 2.5, I think that's 40, divided by 2 is 20 centimeters squared. And there you go. So what I've done is just done examples that are similar to the problems that I'm going to ask you to do for independent practice. So on the assignment 7.1AB, which is loaded to Canvas and you've already worked on, I would like you to do problems 29 through 34 all. So basically just finish up the bottom corner of the page. And make sure you're writing your summary and making little notes in the margins. Okay?